What does it take to make sure an autonomous car can drive 1,000,000 miles? To manufacture a chip for a penny?
Main engines are go.
Or to navigate a spacecraft safely to Mars? The leading innovators who make our world safer, more sustainable, and more connected know that test matters. And their ambitious goals demand a new approach to test. One that helps you get to insights faster, find defects before your customers do, and improve not only your products, but your business as well. It's time to unlock the power of test so that you can engineer the future.
Please welcome to the stage NI EVP, CTO, and Head of Platform and Analytics R&D, Thomas Benjamin.
Good morning and hello everyone. Welcome to day 2 of NI Connect. My name is Thomas Benjamin and I'm the CTO for NI. Yesterday, you heard from Eric and Ritu about NI's differentiated approach to test and measurement and how several of our customers are transforming themselves by adopting this approach. Today, I'm really excited to share with you NI's technology vision, where we leverage the power of insights through measurements to enable a more integrated, intelligent, and automated future. Now, as inventors of software-defined instruments, our heritage has always been enabling you, our customers, to create your own custom test and measurement solutions so that you can reach your goals faster, more accurately, and within budget. Now, we want to take this one step further. We want to help you make test as a strategic differentiator within your organization. Now, let's think about the evolution of medical care. Modern medical marvels are accomplished by patient care teams. By collaborating, staying informed by medical measurements, they provide better treatment as a team. Increasingly equipped with medical measurements ranging from medical imaging, blood tests, to wearable health trackers, these medical teams are constantly working to improve patient care outcomes. This is called connected care, and it is not the future of healthcare, it is the present. Switching gears, let's talk about autonomous vehicles. Modern autonomous vehicles are handling more and more decisions that was previously done by the human operator, empowered by measurements from embedded sensors like cameras, radars, and LiDARs. The onboard computers on these autonomous vehicles function very much like a patient care team, helping you get to your destination safely and reliably. These two examples are not unique. From healthcare to transportation, to aerospace and beyond, technology development across all industries is being transformed by the power of measurements connected to compute and running powerful analytics for the betterment of all. I have seen it having worked in a number of these industries, ranging from transportation to aerospace to e-commerce and supply chain, helping companies make stride to this connected future. One thing I can translate to everyone in this room is that organizations who embrace the possibilities of these connected systems will have a significant market advantage over those who maintain linear, siloed product lifecycle with disconnected data strategies and lack of visibility into product performance. Future success will always require coordination across a number of products informed by decisions technology. Just like doctors who need visibility into your human body, autonomous vehicles who need to look at the road ahead, organizations would need to use measurement data to see into your product and business operation. Now, it's up to the people in this room to make this vision a reality. Today, I'm here to share NI's vision to support this connected world. With NI technology, organization can model the fast-acting, data-driven behaviors of a connected care team or an autonomous vehicle to make next-generation products that the world would rely on. Maybe this sounds like digital transformation, and in a way it is. But what we're talking about here is the power of measurement data combined with the right technology tools to improve your product and business outcomes. Given our history in building connected software-defined test and measurement systems, NI is uniquely positioned to help you get started in this journey. While our competitors are focused on making individual measurement instruments, our vision for the future of test is an autonomous, hyper-automated system of systems, one that can power you into this connected world. And to power this vision, we are investing in 4 core areas. These are interconnected but separate areas, the integration of design and test, powerful insights through advanced analytics, smarter connected test systems, and connected workflows. These 4 areas should not sound new to you because NI is a leader in all these areas. But we are not done investing, innovating in any of these areas. We want to continue expanding so that we can add significant value to each and every one of you. And I'm going to show a number of demos during this day to illustrate this. So let's take a look at what this autonomous, hyper-automated system of systems can do for each and every one of you. Let's start at the very beginning, the design of a new product. For years, companies have been talking about the productivity gains of integrating design and test. We are now at an inflection point in this journey. New philosophies and methodologies like shift left, digital engineering, model-based systems engineering, and virtual validation are leading the way. In general, these approaches all center around minimizing or eliminating the number of design, test, and build cycles through virtualization and simulation. Integrated design and test is a superset of all these methodologies, and it's based on 3 core elements. There are 2 forcing functions that we think is going to take these concepts across all industries. The inclusion of AI embedded in products will change the way in which each and every one of you would design and test products today. Government mandates to embrace digital engineering practices to manage the cost, complexity of next-generation solutions. We often hear in the news the challenges of design and test in autonomous vehicle, but this is not something unique to autonomous vehicle. Embedded AI in this space will democratize to every other industry, and in future, each and every one of you will be designing and testing products with embedded AI. So today, let's see an example from the cutting edge of wireless research to demonstrate the challenges of designing and testing trustworthy embedded AI solutions. So please welcome Dr. Kaushik Chowdhury from Northeastern University and Dr. Amar Haj Omar, NI's internal expert on this topic, to discuss more on this. Welcome, guys. Welcome, Dr. Chowdhury. Welcome, Amar.
Greetings, everyone, and give thanks, Professor Kaushik, for being here.
Amar.
Could you tell us about your research in Northeastern University?
Sure, Amar. I work at Northeastern University, where I research the use of machine learning to design wireless applications that will have good performance and reliability. I started on this journey about 5 years ago as part of a seminal DARPA program which required me to find a unique fingerprint of an emitter. And you can imagine there are network security implications there. More recently, as part of the only wireless-focused AI institute funded by the National Science Foundation, I'm researching ways to do data fusion that combines data from a multitude of different sources like LiDAR point clouds and camera images to speed up wireless decisions.
Very impressive. Can you walk us through some examples that illustrate the value of embedding AI?
Sure, Amar. So first, to safely navigate our roads, autonomous cars must have a highly reliable network connection to a roadside base station. But how would you do this in a complex environment like a city with network congestion, with those reflections from the tall buildings downtowns? So to enable and to solve these problems, we have created digital twins, that is digital replicas of the real world, complete with high fidelity. And models trained on these virtual digital twins can speed up wireless decisions in real time, allow the system to make sub-millisecond level decisions that greatly improves the responsiveness and the reliability of these vehicles in the field. In fact, This has created about an 85% improvement in the performance of the vehicle to find the best possible signal in these network conditions. As a second example, assume that there has been an emergency event and first responders must now coordinate effectively and communicate for a response down to a dispatcher. This means that they must have a very highly reliable network connection. Now, as you can see in the video behind me, initially there is no problem, and the first responders can communicate to the dispatcher. The frame error rate is low. But then an interferer pops up, and because of this, the network is saturated. The first responders are unable to communicate, and the frame error rate shoots up. Now, we've been studying how self-organizing drones powered by these advanced AI/ML methods running on NI USERPs mounted on the drones can cooperate and form a distributed beamforming array. Together, they can restore the signal strength and drive the frame error rate down. In this case, we have shown that this AI models can achieve up to about 40% improvement in the quality of service and about a 50% improvement in the network performance over more traditional approaches.
The possibilities of embedding AI into systems like these are mind-blowing and seemingly endless, but so are the numbers of variables these systems must deal with in the real world. Kaushik, with trust in AI being a huge topic of conversation, what are the key elements to building a trustworthy AI system?
Amir, you're absolutely correct. With great power comes great responsibility. And it is the responsibility of every network engineer and scientist working with AI/ML methods to ensure its safe and trusted use. In fact, from my own experience, there are two very important considerations that you would like to see in this deploying of these systems in a trustworthy manner in the world. First, in AI-based systems, your training data is your algorithm and IP. Unlike a traditional system where you would directly code the behavior you want, in an AI/ML-based model, you would provide it a data set with thousands or millions of these data points, and each such point will give an instance of the input and what the system is likely to do in the real world. So you can imagine that having high-quality training and validating data and then the systems and the tools to manage this data is of crucial importance. And you have to do this before you can trust the system will work in the real world with its infinite possibilities.
This is a really important point. If you want to train an AI to recognize an image of a cat, you can find plenty of data in the internet. But until recently, data needed to train wireless network has not been available. So we partnered with Professor Kaushik, and under the funding of the National Science Foundation, we released an open source code that enables engineers to collect and manage wireless data set, and it's called the RF Data Factory, and it's available on GitHub.
In fact, systems level test is the second most important consideration to ensure that products that are deployed in the real world are deemed to be trustworthy.
And this is the real challenge. Today, most test equipment is based on a model where we have a data sheet that tells us exactly how a product should behave when subjected to a series of tests. But there is no data sheet for an intelligent trained algorithm that must exist in the infinite possibilities of the real world.
So to test such products, we need a shift to a scenario-based testing methodology where we would simulate the world with all its complexity. So in that example, we would simulate the interaction between the drones, the reflections of the buildings, the spectrum congestion, and we can all imagine and understand and appreciate the importance of thorough virtual testing before anything gets deployed in the real world. And even once purely virtual AI testing is complete, the next step is to test the AI-based system with real physical inputs. Now, in a lab, our test and measurement equipment must generate a series of highly synchronized and time-varying inputs and outputs resembling exactly what the real physical system, the real sensors in the system are likely going to see in the real world. And that is a hard problem.
And some might say that's a DARPA hard problem. Years ago at an NI Keynote, we featured a system called the DARPA Coliseum, which is a parallel channel emulator. The Coliseum is one of a kind that combines hundreds of NI software-defined radios with massive real-time processing. Once the DARPA challenge concluded, it was entrusted to Northeastern.
That's right, Amir, and I believe we are very fortunate to have a resource like the Coliseum at Northeastern. In fact, that drone experiment that I showed you earlier required us to emulate the system in the Colosseum and gather valid training data to refine it and test it under very good emulated conditions. But there's one problem. There's only one Colosseum in the world.
Which is why we started here at NI to scale these capabilities to every engineer. In the demo on the screen, we've produced and enhanced the capabilities of the Colosseum, but within a single PXI chassis with processors and FPGAs. Basically, the Colosseum in a box. In this demo, we have 2 wireless transceivers communicating with the real-world environment, Austin Airport Traffic Control Radar Tower. To emulate our device under test, we've built a very simple AI-based system which detects degradation performance. It learns to frequency hop. The degradation is due to the high power levels of the radar. As Professor Kaushik said, when it comes to testing, the first element is to do as much as you can in a purely virtual world. And on the left, you can see us doing just that in a software simulation tool. But the final and the real challenge is to be able to test your prototype and emulate it in that environment. So on the right, you'll see that we've emulated the physical environment on the PXI chassis, where you're able to connect your device under test, inputs and outputs, tricking the device to be able to believe it's working on the real world, but in the convenience of your own lab.
Amar, while I know this technology is still in its infancy, I think NI's ability to do this kind of methodical testing at a desktop will revolutionize the way the systems are designed and then deployed in the real world.
Thank you, Dr. Kaushik and Dr. Omar. Now, so it's great that we have people like them working on some really complex problems like this. So let's recap. What we just saw was an example of products. As products get much more complex, test has to shift left to the design process. And the challenge of testing embedded AI that Dr. Chowdhury faces today is something that would apply to each and every one of you very soon. And when it does, NI will be there with an integrated design and test solution to help you. Now, beyond embedded AI, measurements have broad applications across the entire product life cycle. In fact, we believe that test and measurement data is the most underutilized asset within your organization. Now, how can we say that? Because after they are used to verify a product checkpoint or sign off on quality, where do they go? For the most part, nowhere. They are either discarded or archived. But why is this? This data should live beyond its initial purpose. It should be part of the engineering and operations strategy of every product in every industry. Yet, for some reason, it is not. Last year, on stage here at NI Connect, you had Qualcomm, who essentially were able to speed up the time to market from 3 years to 6 months by using advanced analytics on large batches of validation data. At Qualcomm, they're combining large batches of test data into a common platform to drive engineering and product decisions. But we believe that measurements can go even further. This belief is the core of our second pillar, automated data insights, which is based on measurements adding value to the entire product cycle. So to help explain further, I'd like to welcome on stage our VP for Software and Offering, Shelley Gretline. Welcome, Shelley.
Thanks, Thomas.
So hi, Shelley. Could you tell why measurement data is so important and why now?
Of course. Focusing on measurements is not new to NI. We've been working with our customers for decades to ensure that their measurements improve their product outcomes and their business performance. In fact, it was probably 10 years ago or so on this stage, Airbus was here, using measurements at the edge to ensure the torque of every fastener was just right. They were doing smart manufacturing before it was a thing.
And this was one of our first projects, and this concept is what is known today as Industry 4.0.
That's right. And since Industry 4.0, now processing at the edge is a given. But of course, your challenges and our capabilities have evolved significantly. We now have a modern data and analytics platform that allows you to generate more insights. And those insights allow us to have a greater impact at the engineering, product, and operational level.
Now, this aligns our capabilities with your technology initiatives that you have today. You are trying to do more with data and analytics so that you can realize technology outcomes like better insights, decision support, and automation. These are no longer new concepts. What is new is how NI can enable you to be widely successful in these initiatives. On the foundation to all this is measurement data.
That's right, and that's true across all the stages of the product lifecycle, but it's super clear in production. In fact, if you start adding measurements into your technology integration projects, you can start doing adaptive manufacturing. And we're seeing customers that are doing this already see incredible results. 50% reduction in scrap, 25% cycle time reduction, and 10% increase in yield.
Now, this concept may not be new to some of you. Using product data to actually improve products, it is your basic feedback loop. So while it's easy as a concept, it is actually not easy to execute, because to do this, we need to integrate information and systems across different teams and different operations, and this requires constant collaboration. And this is where NI can help you with our foundational data models.
That's right. Your organizations, I know, I visited quite a few of you, are full of silos, right? You have your supplier data for your raw materials, you have your test data for your maintaining your uptime, you have your validation data, and all of these data sets track important parts of the product through the life cycle. But the foundational data model brings all of this data together so that we can see the insights as to how and where we need to improve.
Now, jumping straight into this broad, comprehensive data view may not be possible for all organizations, but that's okay. We can start our implementation with one product or one process at a time, no matter how big or small you are.
That's right, and that's how most customers actually approach this problem. We use SystemLink as our data-centric test model, just like we did at GM. And SystemLink is built to handle test and test-adjacent data, like test, simulation, specifications, those sorts of things. And this allows test organizations to tackle their test problem today, from validation lab all the way to production. But something that's not everybody knows is that SystemLink helps test team, beyond the test team, right? It also creates the data for the rest of the organization to use.
And once the organization realizes the value of measurement, we then look to Optimal Plus and our more operation-centric data model, which is designed to make processes and inputs and things that collected together into one homogeneous build. Think of it as a collection of digital twins. Each digital twin of a product represents the inputs to the product, the suppliers who produces it, the processes who made it, the quality, the measurements that go with it. And this is all what we call as the genealogy of the product. And this hierarchy can be applied to pretty much any product, whether it is an ADAS camera, to batteries or pacemakers and more.
Exactly, and that's how we break down those silos with data. The foundational data platform associates the input variables with the product outcomes that you want. So that feedback loop is really what unlocks the effectiveness of your analytics and your automation. And what's really cool is that in most cases, the measurements are the product outcome. Let me give like a super simple example. Let's imagine we're gluing a component onto a motherboard, right? And as is very common, that placement can drift over time, causing the component to fall out of quality spec, sometimes creating rework, scrap, all kinds of quality issues. Now, of course, we want to correct the issue, but oftentimes there's so many different variables, we don't even know where to start. The placement machine may be off, there may be a defect in the raw material that's causing the issue. It's only with the right alignment of the product outcomes with those inputs that we can make the correlations. So this is why our measurement-driven approach is so impactful. With that product-to-process feedback loop, it's easier to extract those insights. But we're not done. It's not just about the insights. We have to go that last mile. We have to turn the insights into actions to actually make a change, and that's how we make the biggest impact.
So our tools essentially take the root cause correlations into corrective measures, and we embed these corrective measures into the production process. The model uses the real-time data, the same data that feeds into our data platform, and we watch for patterns that trigger these anomalies, identify the corrective measures to address this, and then embed them in the manufacturing process. And this is what we call adaptive manufacturing. It 100% depends on measurement data.
That's right, and we use those measurements in this way to create fewer quality issues while we increase our yield and effectiveness. And we didn't have to jump straight into some huge smart factory project.
That's right. We just moved from a series of projects loading one set of data into a platform using product-centric analytics to identify the root cause to solve a problem and then go into the next process. And we are now slowly on a way to enable a more expansive, realistic production process.
That's right. And I want to add one more really exciting element to the mix, Thomas: machine learning. The NI approach and our software tools create the perfect infrastructure for machine learning operations. We're taking this technology from a data science project into the real world via your lab and your production floor. And as your products and processes become more complex, machine learning can be a competitive advantage for you. So how does that work? We take that same foundational data model we're talking about, and we use that as our validation and training data set. We then think about product-centric analytics, and we use a supervised machine learning model to connect that to the product outcomes. Then the actions. We can embed that machine learning model into all of our processes in the lab or in production. And it's trained to look for those data patterns, and then we program it to respond when it finds those patterns. So now you integrate this into your MEMS, into your test system, your machine control, and now you're driving impactful automation. And soon, we won't have to pre-program those responses, right? AI will be able to tell us exactly the right next best action. So this innovation ensures that test continues to be a competitive advantage for you.
Thank you very much, Shelley.
Of course.
So beyond spreading these concepts that are discussed today at your companies, we also want to give you a set of tools that can actually demonstrate the potential of automated data insights. As an example, let's look at the semiconductor industry and a new wafer classification tool that is already deployed at Renesas and see what's possible. While all of you may not make semiconductors, the concept of using measurements to classify products is relevant to all of you. After fabrication, the wafer sort process uses test results to bin or scrap each die. This is critical to the quality, yield, and profitability of the semiconductor line. With our new wafer classification tool and the Optimal Plus platform virtualizes the process of bringing decision support, automation, and consistency to the wafer sort operation. From day one, pre-trained machine learning models can recognize standard set of wafer failure patterns. Those results are then made easily available to be visualized on a dashboard. Panels will automatically update based on selected tags so that you can essentially sort and investigate this even further. Plus, by prioritizing the wafer review process on those models, the model confidence slowly evolves and incorrect classifications are easily identified. With manual corrections, the models can improve over time. Our interactive user interface makes this possible with just a few clicks, and the back-end analytics does the rest. Standardizing around a more intelligent and predictable wafer sort process leads to faster, more consistent wafer results. Not to mention, it is now part of the Optimal Plus ecosystem, better connecting the entire test and assembly process for more advanced insights with improves yield, quality, and efficiency. To see more, there is a detailed demo at our booth in the Experience Lounge. Please visit it and take a look at it. Now, we'll continue investments into the latest data and analytics advancements so that you can essentially make better decisions, create better results, and improve your production KPIs. Now, for the last 30 years, instrumentation systems have been PC-centric, but the evolution of IoT and cloud technologies promises to revolutionize the design, maintenance, performance, and cost of test systems of the future. From compute that scales up and down based on your requirements, to the elimination of tedious tasks like installation and maintenance of test system software, and a set of brand new measurements that deliver deep insights beyond waveforms, test systems will become more smarter and more connected. To give us an example of this from the automotive industry, I'd like to welcome on stage Eli Carey from NI and Ben Reitzman from the Battery Innovation Center. Welcome, guys.
Hey.
Ben?
Hi, everyone. Let's talk about the massive transformation that's happening to electrify vehicles. The critical and limiting factor in achieving this ambitious goal is the availability and the production of better batteries. So never before has one component had such far-reaching implications for the quality, the safety, and the performance of the final product, while it itself is also undergoing such a rapid pace of change and innovation.
Hi, everyone. I lead the Battery Innovation Center, where we advise these automotive organizations on how to ramp and scale their next generation battery technology, which has a huge dependency on test. Batteries present a really unique use case for test, as they have unique coverage requirements. Most of you here today are probably testing an electromechanical system, but with batteries, we actually add a chemistry into that mix. You could argue that testing a battery is closer to testing the human body than to testing a circuit board. And like humans, we're highly dynamic. Our conditions change based on our usage in our environment, and each one behaves a little differently.
And like humans, they're very different. So as we see, batteries have a wide variety of form factors, sizes, chemistries, capacities, et cetera. So this requires that we have measurement systems that are both very capable and very flexible, so we can get the data we really care about. And what's interesting here is that the rapid pace of change and the evolution of batteries is really requiring that we evolve the way we test.
Yes, that's true. And for example, one of the common quality objectives is to observe how well a battery keeps its charge. However, this can be hard to detect, and it takes a long time to test.
Yeah, so today it's no secret that the industry tends to rely heavily on legacy methods that provide limited insights. So if we want to build better batteries, and if we want to do things like root cause problems, we need more advanced and more capable measurement solutions that really let us understand the inner workings of a cell, right?
Yes, and the best way to do this is to profile the impedance of the cell. Cells have a resistive component, but they also have an inductive and capacitive impedance.
So let's take a quick look at an example. The data we're showing here shows the results of an increasingly popular method known as ACIR, which injects a kilohertz tone to a battery to try to characterize the internal resistance of a cell. Now, we're just looking at 2 data points from 2 cells here, but they're clustered together such that this would suggest they're equally good. But in reality, there's a defect that we're not seeing as a result of this methodology. So if we instead apply NI's cell quality solution, which is based on our PXI instrumentation, we can actually expand the set of frequencies we're injecting into the cell and perform something called electrochemical impedance spectroscopy. So when we do this, we can actually see the response across a larger spectrum, and we can see that one of the cells has actually undergone premature aging, suggesting that there's an internal defect that we otherwise would have had no insight on.
This is really impactful. The right hardware and measurement technique will directly translate to better quality and improved yield. However, this still won't be enough on its own. We need to scale these measurement techniques from the lab into the production environment, which is another problem entirely.
So Ben, will you explain what is it about battery production that makes quality and yield so difficult to manage?
Sure. Well, it can take from several days to several weeks to build a battery, and there are a ton of lengthy steps which can induce defects into these little guys. Imagine these giant bookshelves and racks full of batteries, thousands of them all over the warehouse that are forming and baking in process. Our goal is to reduce this manufacturing time from those weeks or sometimes longer to just a matter of hours and days and decrease the points of failure.
Yeah, and so key to achieving what Ben's describing is we have to move away from just having test at the end of line. We have to look for how and where to better insert test throughout the manufacturing process so we can find those defects sooner and closer to where they're being introduced. But if you think about the scale of the operation he just described, this results in thousands and thousands of test and measurement nodes. So this really requires streamlined asset management in order to effectively orchestrate, control, and manage all of these endpoints. And this is really what we mean when we talk about connected and the smart connected test systems.
And once connected, anyone in the organization, anywhere in the world, can find, manage, or update these test assets. New test measurement techniques can be deployed to extract new data across those different processes. But now that our test systems are connected, they need to be smart.
Yeah, so we do this by combining the test assets with local compute. So, of course, this allows us to create adaptable, automated, smart test systems and test ecosystems. So it really comes down to the data and the value of that data being produced. So of course, everyone making batteries is increasingly concerned with and focused on the data, but it's bigger than just the data from one test. It's really about the data across the life cycle of that battery and across all the manufacturing activities. That data stream needs to follow that unit. If it sounds familiar, this directly plugs into what we talked about earlier with our automated data insights pillar.
And this modeling is becoming a part of the secret sauce for each battery manufacturer. It helps them characterize a unique way for each of their characteristics of each of their battery cells. Will it be a great cell? Is it a bad cell? Is it a marginal cell? Even better, once classified, can we identify why? These evaluations are critical into improving yield and minimizing quality escapes. Clearly, NI technology is a key enabler to create and deploy these proprietary models.
And Ben, it's really a pleasure working with you and your team to advance the state of the art when it comes to batteries. So thank you so much for everything you do.
Of course, thank you.
Thank you, Ben.
So to continue Ben's final point about battery and battery technology, I want to show you in the audience something. So we talked about cell measurements and cell quality, and we've talked about distributing it throughout the manufacturing process. But we want to take a look at how we can extend that further. What we're looking at here is actually an example of a cell formation tower. Now, for anyone not familiar with batteries, this is a critical part of that lengthy manufacturing process. It takes newly built cells and actually creates the SEI layer over a series of days. The key thing is that this process often means that you don't really understand if you're getting a good cell until after that multi-day process has concluded. What we're looking at is an example system that actually integrates some of those same measurement capabilities we just described directly into this manufacturing process. So this helps us understand and monitor the state and quality of those cells throughout that process. It also unlocks additional value, like the ability to combine multiple cells in a series string across a single cycler. Now, as a result of having all of these endpoints connected in my formation tower, I can do things like remotely monitor and track the status of my overall manufacturing system or an individual cell. So this web-hosted dashboard is allowing me to see the status of my manufacturing line and dive into the particulars of a single cell. But Thomas, it goes beyond the value of just remote monitoring. A smart connected test or manufacturing system like this one is really enabling a system of systems. So we can get insights from one cell, but again, that can be combined with insights across the entire production floor and even validation labs. So we're able to adapt the formation recipe and ultimately produce higher quality, better cells.
No, thank you, Eli, for your demonstration today. Thanks, guys. Let's give him a big round of applause. Now, EV batteries are a great example where test systems are becoming smarter and even more connected. But across almost every industry and application system requirements are becoming complex, and there's new needs for advanced measurements. Now, in our last example, we talked about precision, low-frequency measurement systems. On the other end of the spectrum, we are happy to announce today a new sub-terahertz measurement solution that is required for the 6G wireless systems. Based on PXI VST3 and a powerful FPGA coprocessor, this measurement solution supports up to 4 gigahertz of instantaneous bandwidth at frequencies of up to 173 gigahertz. This solution includes out-of-the-box software examples, and I encourage you to check it out in our experience loads. Now, what we have seen here are 2 examples that represents NI's unwavering commitment to be at the forefront of test system technology. From high voltage to high channel count to super high frequencies, we will be there for you with a smarter, better connected measurement system. Now, with our last pillar, we take a look at one of the most enduring challenges for any test organization. With a growing set of software languages, test hardware, and test engineer personalities, it can be impossible to standardize on a common set of measurements that everybody must use. What you may gain in efficiency through reuse, you cannot lose through lack of flexibility, extensive retraining, or frustration of your test engineers. With connected user workflows and its 3 core elements, NI has a way to address this challenge by extending some of our current software capabilities. So to discuss more, I'd like to welcome on stage Darcy Dement from NI and guests from NXP, Wolfgang Rominger and Eric Perraud. Welcome to talk to us about some of the software innovations they're working. Welcome, guys. Welcome, Darcy.
Hi, Thomas.
Eric.
Well, thanks, Thomas.
For decades, NI has provided industry-leading software to accelerate the development of test and measurement systems. Now we are working to further increase the productivity of test teams, which is what Wolfgang and Eric are here to talk about. So Wolfgang, could you start with an introduction to your role and how your team approaches measurement development?
Sure, happy to, Darcy. Thanks for having us today. So I've been working in semiconductor validation for over a decade, and lately I've been responsible for architecting automated measurement systems. So what we do in post-silicon validation is we manage the process to develop measurement solutions for several NXP products. And over time, we have created and collected many different approaches that we use to automate our tests. However, different teams using different technologies makes it quite difficult to scale and challenging because everyone is using different programming languages.
Yeah, absolutely. This is a common challenge that we've heard from customers. And indeed, as you said, it only gets more complex as you scale. So how does this impact your team day to day?
That's a great question, Darcy. So given the lack of standardization, each team has to develop from the ground up their own software infrastructure. And those teams' time is then spent on developing the framework rather than testing the products. And this is quite challenging to overcome. Therefore, we have been partnered with NI for a pilot project, which enables teams to develop test code in the language of their choice and simplifies the process of sharing these measurements. And I will turn it over to Eric because he knows much more about that since he worked with it.
Thanks, Wolfgang. Yeah, in this pilot project, I've been evaluating how to create measurements using tools like LabVIEW and Python. This starts through defining my virtual instrumentation and manually create the right measurement plan. Then we often want to scale and automate that measurement with test sequencing. And this alone can be very difficult to do software, hardware, and driver dependencies. So we needed a better way to share.
Yeah, absolutely. Some of you might recall that we teased this concept at NI Connect last year. And as you heard in yesterday's keynote, I'm pleased to announce that this concept is now available as a new product, Measurement Link. Now every test developer can create measurements using the coding language of their choice and the instruments they need, whether from NI or another vendor. Then Measurement Link does something powerful. It makes this code accessible as reusable, ready-to-run measurement blocks that you can run interactively in Instrument Studio or in an automated sequence and test stand without writing any additional code. And because interoperability is designed in, it makes sharing across people and teams really simple. And we're thrilled to have NXP as a lead user. So Eric, how do you plan to use this going forward?
So for my use case, was able to quickly create measurements in LabVIEW and Python and really focus on the implementation of the measurement. We expect that this will help reduce development time by 50%, and I didn't even have to worry about if the other test engineers have the same development tools installed or could understand how the measurement was developed.
And this is extremely important with tight schedules and our team's wide variety of skills. So ultimately, we want to work towards publishing a central measurement library as a trusted resource for all teams, which hopefully help to decrease the redundant development effort and improve the collaboration among teams even further.
So Wolfgang, Eric, it is really great to see the initial progress you have made, and we are really excited to see where you guys can take it to the next level. Thank you very much.
Thank you.
Thank you.
Thank you. So our innovation teams are actually exploring that shared measurement library concept that Wolfgang just mentioned. To give us a peek into this project, I'd like to welcome Chris Cifra and Alejandro Barreto to the stage. All right, morning, guys. So, Chris, just tell us what your team has been working on lately.
Sure. We're working at how to complement the local test and measurement development process with a cloud-hosted repository of ready-to-run measurements. This includes options for multi-user collaboration, simplified deployment processes, and historical archiving.
Okay, so let's back up a minute. So we've used that term already a few times this morning, ready-to-run measurements. Could you define a little better what we mean by that term?
Sure. It means we're storing the compiled, deployable version of measurement software, making it accessible to the entire test team without having to know anything about the underlying source. This includes the software and driver dependencies that will automatically update. This is a huge benefit. No more manual checking system states, no more manual updates. Ready to run is similar to the concept of plug and play, but for measurements. It might be best to show you rather than explain it.
Yeah, absolutely. A demo is always better, right? Yeah, let's see it.
All right. Alejandro and I are going to play the role of test engineers who work for the same company in the same or different locations. The goal is a test collaboration experience that delivers measurement standardization and shareability across the entire organization. We refer to this as Test Hub, a central location for measurement libraries and test automation. When I log into Test Hub, I can search across all of my measurements. Most of these will be from different people in my organization, but some could be provided by vendors like NI. As a central repository, I can search by DUT properties and other relevant tags. In this case, I'm interested in this measurement. It's a 2-channel converter efficiency measurement. But in the lab today, connected to the PXI, I happen to have a 1-channel converter. So I'm going to need some modifications to this measurement. If I look at the properties, I can see that Alejandro was the original author of the measurement. Let's go ahead and send him a message and ask for some assistance.
Great. As another team member using Test Hub, I can see that Chris is asking for some help with a measurement that I developed. And I'm going to help him out. So to do that, I'm going to open up Visual Studio Code. As you can see, we've integrated Test Hub into VS Code, bringing Test Hub to where you already do development. Right here from the Test Hub pane, you can create a new measurement in all your favorite languages like .NET and Python, and of course, LabVIEW. You can also see your existing measurements in this list up here. I happen to have the 1-channel version ready that Chris wants. So let's edit it and let's click on the edit button and take a deeper look. So as you can see, the measurement is regular Python code. Let's go back to the Test Hub pane. I can then publish with one easy click. Yes, just one click will package your entire measurement and share it with your teammates. So let's go back to Test Hub, where I'm going to find that 1-channel test. And I am going to just @mention Chris and let him know that it's ready for him to use.
OK. I see now a notification that my new measurement is ready here, and I can see it in the measurements pane. Let's start with an interactive experience using Instrument Studio, where I can begin to explore how the measurement works with my device. Once I'm ready to deploy, the benefits of Measurement Link and Test Hub work together to significantly improve my workflow. Since these are ready-to-run measurements, deployment is designed to be a simple one-step operation. In this case, Alejandro used Python to write his measurement and a device driver. I don't have Python installed on this computer, and I do not have that device driver, and I don't need to. With one click, I am using that measurement with all those details taken care of for me by Test Hub, and I can get the testing faster than ever before.
OK, so that is very cool. What you just showed means that you, as a user, don't have to install and manage your software and drivers on your test system. Test Hub takes care of that for you. Right. And that is something that we've wanted to be able to do for a very long time. It'll now be easier than ever for teams to collaborate and deploy their measurements. That's very exciting. Thanks a lot, Chris and Alejandro.
I'm really excited to see Test embrace new technologies to streamline processes like what you just saw. Now, you know that engineers have a number of choices when it comes to tools that use. But how at NI, we believe we know Test better than anybody, and we are committed to creating a workflow that is not just a general purpose workflow, but one that actually works for each and every one of you. Investments in products like Test Hub and close collaboration with lead user customers like NXP can help us get things to market faster so that we can simplify the life of test engineers. So today, we've seen the vision of autonomous, hyper-automated system of systems and how it can accelerate product performance. I was so proud to showcase the examples from many of our engineers, design partners, and customers with whom we collaborate really well. But I'm not done yet. Across all these 4 pillars, the teams are committed to taking this technology even further. We must continue to innovate on our platform. We must continue to build workflow connections and advanced analytics. We must continue to question every new technology. asking how it could be adopted to deliver better product and business performance. We have one more thing to show you, and this is from our labs. All of you have heard a lot about advanced AI and large language models and things like that. Now, how does this apply in the test and measurement space? Now, let me remind you that this is an R&D prototype, and in future, we would only incorporate it in our products after it has undergone rigorous and complete testing. But what could this experience be if we could have AI powered by large language models act as a virtual test engineer? So I have Alejandro back on stage to show me what's the art of the possible. Take it away, Alejandro.
Thank you. Hey, everybody. I'm here again to share what we've been working up in the labs. So this is an AI assistant that can code in LabVIEW, and his name is Nigel. I want to show you today how Nigel can make your life easier. So let's start by asking it what hardware I have connected to this system. So what USB hardware do I have? Great. It's going to mention my simulated NI USB 6003. And so right there, it's generating a table, giving me information on my hardware, the different channels. And I suppose it's also going to give me a pinout, help me connect it. So let's use it to make a measurement. So let's acquire data from AI3. Right. I didn't mention the number of samples or the sample rate. And that's great. The AI is asking me when it doesn't know instead of just guessing. So let's fill this in. Let's say 100 samples at 200 hertz for a measurement just under 1 second. So it looks like it's generating a VI. So this might take a little moment.
So this looks like ChatGPT.
Well, not quite. ChatGPT can write blog posts and emails, but Nigel can control your physical hardware and connect to your apps like LabVIEW, TestStand, and SystemLink. Nigel is tuned for test and measurement for the things that you all care about.
So how does this work?
So we built our AI on top of GPT 4.0 and trained it on NI hardware and software. Then we connected it to the LabVIEW API and taught it about DACMX. This is the first time that I know of that an AI is generating graphical code, and this is only day one. It is apparent that we are only scratching the surface of what this is capable of. It's a really exciting time, Thomas.
So Alejandro, as a software engineer, how do you think such capabilities could change your day-to-day life?
Yes, so this helps me focus where I can add the most value using my expertise. Not deep in documentation or little details. Now I can spend more time on my ideas, solving problems, gathering insights, and doing more of them. Nigel gets me there faster. So it looks like it's done. And so I'm going to send this VI to LabVIEW, and let's take a look. So there is the front panel. We'll come back to it when we run it. Let's go to the block diagram, just verify that it did what it did. Oh, look at that. This is for the guy wearing the We Want Zoom shirt out there. We heard you. So let's run this VI and see if it did the right thing. Look at that, a waveform. It worked.
Oh, this is great, Alejandro. You know me, I'm going to be looking for something much more detailed. So is this the only thing that it can do?
No, Thomas. Nigel can do more. So let's just reset this for a second and get started. So let's go back to that DC to DC converter that we were using in the earlier demo. I see here, Thomas, that you actually sent me an email earlier asking me to characterize the power efficiency of that converter at various parameters. So I went ahead and downloaded the spec sheet for that converter board in this PDF, and I'm just going to drop it into the chat. And as I do that, the AI is reading the spec and learning about that DC to DC converter. So the next thing I'm going to want to do is, well, how about if we just take your email as is? Let's just copy and paste it right into the chat window. And immediately, the AI starts responding to your need. First, Nigel is giving you a wiring diagram for the DUT that you asked for with all the hookups to our PXI in the lab. And then, as soon as it's done with the wiring diagram, it's going to start making that VI. Now, this test is a little bit more complex than the last one that we saw. And so it's going to take 3 minutes to generate. And we don't have that time today and during this keynote. So I'm just going to stop it, and let's take a look at one that it generated earlier. So I'm just going to open it up. This is the actual VI that it generates. And as you can see, this VI does a lot more than the last one. It performs 2 DC power acquisitions, and it even does math to calculate the result. Look at how much code this generated in 3 minutes.
Now, this is really impressive because this would allow engineers to spend more of their time on what it matters.
Yes, and I'll admit, for now, this VI is a little messy. But the important part is that it works as is. So let's drop that VI right into the chat. Great. Looks like Nigel has read and understood the VI that I dropped into it. So I've connected the APIs for TestStand and SystemLink into Nigel, which will allow us to deploy and run distributed systems right from the AI. Let's have Nigel deploy it to our lab here on stage. So I'm just going to say deploy it to the lab. Great. The AI will respond with a list of systems to deploy to. Let's pick the one that's right here on stage. My buddy Chris is here in the lab to help me run this test.
Welcome, Chris.
All right, so let's select the one right here in the Convention Center. The AI will wrap the VI in a TestStand sequence, perform the voltage and current sweeps that, Thomas, you asked for, and then deploy it via test hub to the lab. Great, it's done. Let's have Chris in the lab run our test.
All right, thanks to Test Hub and Nigel, I have everything I need to run my test. Let's give it a try. We can see it running. And the test passes.
So thanks, Chris. And as you can see, Nigel has done exactly what Thomas asked for.
So remarkable, in less than 5 minutes, we went from spec to test, giving you insights into your DUTs, which would have normally taken you about half a day. So let's give a big round of applause to Alejandro and Chris. Thank you, guys. Now, it's AI technologies like this that can actually simplify the life of the test engineer. Our day-to-day workflows are surely going to change with the emergence of new technology, and that is a good thing. So I started this keynote by giving an example from the medical industry. Doctors and nurses use measurements as a leading indicator in a surgery or a treatment. This is an example of an autonomous, hyper-automated system of systems in action for mission-critical scenarios. So in this room, we are all experts in test and measurement. The 4 key elements that we showed today have the potential to speed up your time to market, diagnose issues in your products and processes, and identify and improve efficiencies in your business operation. So today in this conference, I challenge each and every one of you to be bold in how you use technology and measurement data to drive product and business performance. Thank you for your time today, and enjoy the rest of the conference. Thank you, everyone.